Hi, this is Phil from Simply Rhino, and this is Rhino 6 for Mac. In this video, I'm going to look at a quick summary of the new and improved features that are now available. There have been improvements to modeling, rendering, display performance and presentation, plus of course Grasshopper is now included. Broadly speaking, Rhino 6 for Mac has the same feature set as the Windows version. There are some exceptions, however, most notably limited plugins and the lack of work sessions. The interface is different too and adheres to the usual macOS interface guidelines. On startup, Rhino for Mac will look like this, and I would suggest that if you go to Preferences and choose Themes and then choose Rhino for Windows, this, rather than bringing up a Windows-style interface, will add the top tabbed toolbar where you will have access to the majority of the Rhino tools available. And I'll see this next time I open a new document. Rhino for Mac takes full advantage of the system-level features of Mac OS, and this is most notable when saving a file and reverting to previous versions. Mac OS saves incremental backups, called versions, automatically, but you can also create your own versions by using the save command. The easiest way to explain this is to demonstrate it. Here I have a new model that as yet I've not saved. So I'll go to the save command, save this onto my desktop, and I'll call this test. Now I'll make a change to the file by deleting the geometry, changing layer, and drawing another primitive, this time, for example, just a cylinder. And to create a version, I'll just save. Then I'll delete the geometry, make a change to the layer, and then create another primitive. Create a version by saving, and then finally I'll do one more step. And create another version. Now, if I don't hit save, the macOS will perform incremental saves every so often. But if you get to a significant stage in the file and you feel that at some point in the future you may need to recover it, then using the save command is not a bad idea. At this stage now, if I want to recover earlier versions of this document, I can go to File and Revert, and I can browse all of the versions, and this will take me now into the Mac OS dialog. And here I'll be able to toggle between the versions that I've saved. So here's the version with the sphere, here's the version with the cylinder, and here's the original version with the box. Each of these files here can be previewed, and I can also restore the version, or I can copy data back into the existing document. So I can either restore here or choose not to restore by hitting done over here, and then I can paste the box that I created earlier back into the existing document. Another system level feature that Rhino 6 for Mac takes advantage of is the dark mode. If I go into the Mac system preferences, I can go to General, choose the dark mode, and you'll see that Rhino changes all its menus and its interface to the OS guidelines for dark mode. Rhino 6 introduces some significant modelling enhancements, including a much wider adoption of history. Here I'm going to look at the Match Surface command on this simplified example of a boat hull and deck. The premise here is that I want to be able to adjust the whole surface and maintain the edge between the hull and the deck. Both of the surfaces are degree 3 with 4 control points in U and V, and they have been built so far without history. So I'm going to turn on history, and then I'm going to go to Surface Edit and use the Match Surface command. I need to first of all pick the surface edge that I want to be able to be changed. So this will be the deck, and then I want to pick the surface edge that is going to drive those changes. And here I just want to match for position. I don't want to match, for example, the tangency, because I want to keep this sharp edge. So I'll run the match command, and I've now established a history connected match between these two surfaces. So if I were to now turn on the control points for the hull and now pick, for example, these control points here, and then adjust these using the move UVN command, then you can see that as I move this surface, that the deck edge moves with the edge of the hull surface. So this is a neat way of being able to keep surfaces separate so that they can be point edited whilst maintaining the concept of a bonded edge. One of the most significant features in Rhino 6 is how the blend surface command now works with history. In this example here, the curves that I'm just highlighting here are history copied versions of the curves on the left. So with these curves on the right, I'm going to build a couple of surfaces. So first of all, I'm going to create a revolve from the blue curve here. The start of the revolve axis is going to be that point, and I'm going to enter to accept the C-plane Z-axis. I'm going to start the revolve at 0 and end at 360 degrees. Then I'm going to build a loft between the three red curves over here. And I'll just accept the default options here. So the premise here is that because I use history connected curves and I've got history turned on, that if I edit the curves over here, then obviously this surface will update over here. Now if I want to create a blend surface between these two curves here, I'll go to blend surface, I'll pick the top edge of the loft and the top edge of the revolve. I'll check that my curve seams are coincident, and I'll run the command. I'll switch maybe to tangency, and as you know, I can play with the shape of the blend either with these sliders or with the blend handles themselves. So I'll accept that result. So the changes in Rhino 6 are this, is that if I now, for example, make changes to either of these surfaces, and I can do this with, for example, the curves that created them, then you'll see that the blend adjusts. So just make a couple of simple changes over here, and you can see how this blend keeps adjusting. Okay, so that's the first part of the history connection. But the other part of the history connection is this, is that if I go back in to the blend surface command, you'll see I have an edit option. I can pick the blend that is editable, and I get back essentially into the preview. So I can make changes to the shape, and I can even change the matching. So in this way, I can maintain the adjustability of the blend and also have the blend adapt to changes in both of the surfaces that the blend is created between. So in real terms, all three of these surfaces are adjustable and yet stay continuity matched to each other. The adjustable blend curve command also has similar history enhancements to that of blend surface. Before I demo this, however, I just want to explain a new behavior in Rhino 6 and how, if you prefer the Rhino 5 method, you can revert to this. And that behavior is this, is that if you select a curve now in Rhino 6, the control points are visualized. And if you work with control points a lot and you have a number of curves that have control points on and a number that don't, then you might find this behavior confusing. And so to revert to the Rhino 5 behavior, you can go to the Preferences, you can go to Mouse, and you can turn off this option here, turn on control points when selecting a curve, light, or annotation. And now, when I pick a curve, I get back to the Rhino 5 behavior. Okay, so let's now have a look at the adjustable curve blend command. So I'll go to Curve, Blend Curves, and Adjustable Curve Blend. I've got my history turned on here, and I'll create a blend curve between here, and just to keep things simple, I'll match the tangency. As you know, we can move these handles here, and we can change the shape of the blend whilst maintaining the tangency. So I'll accept the result here. Now with history in Rhino 6, if I move either of these curves, then the blend adjusts to maintain the specified continuity, and this happens whether I move the curves or whether I point at it. Also, I can go back into the adjustable curve blend command. I can use the edit option, pick the curve in question, and you'll see that my points are now visualized. I can get back into the preview of the command. I can change, if I want to, the continuity and accept the results. And so, just as with blend surface, these three curves are matched with history, and I can adjust any three of the curves independently of each other, and the match will be maintained. Fillets have been much improved in Rhino 6, and for the most part they're now much more robust and fail in fewer cases. Here's an example in version 5, and typically this type of geometry would cause problems. We have a number of curved faces that are all at different tangencies to each other, and a sharp corner that runs into an existing filleted feature. So if I attempt to fillet, for example, this top edge with a 10mm fillet, and I pick this edge here, then you'll see that if I turn on the preview, you'll see it looks as though the fillet is going to build but not trim correctly, and when we build the fillet, you'll see we have a portion of the fillet, but both the interior and the exterior trim are not built correctly. Similarly, if I apply a smaller fillet, for example a 4mm fillet, along this existing edge here, then again the fillet, although building correctly into this corner, will fail to trim into this sharp condition here. If we now switch to version 6, you'll see that with the exact same geometry we get the correct result. So I'll go to Solid, Fillet Edge, and Fillet Edge. I'll set the radius to 10, and I'll look first of all at this corner here. If I go into the preview, you can see that the fillet appears to trim correctly on both ends, and then if I enter and select the geometry, you can see that the fillet builds correctly and I have a closed solid polysurface. So the fillet is trimmed up correctly. Again here I'll go into the fillet edge command, I'll set the radius to 4, and now we'll look at going into this corner and out to this sharp corner, and again the fillet builds correctly. Now there's another option that's new in version 6, and this applies to fillet edge, blend edge and chamfer edge, and that is that once I've in this case added fillets to an object, I can go back into the object and edit those fillets. This option allows me to edit the fillets in the reverse order in which they were created. So in this case, if I wanted to edit the 10mm fillet that I applied to the top, I'd first of all need to undo this 4mm radius and return this corner to a sharp edge. So let's have a look how we approach this. So I go to the fillet edge command and I run the fillet edge command and I select the edit option. I'm then asked to choose the object that has, in this case, fillets applied to it. I'll select this geometry here, and then you'll see the last edge that I filleted becomes highlighted. If I hold down the command key and left click, I can remove that edge from the selection, and if I then go to the edit button again here and again pick the geometry, I'll now get to the 10mm top radius. Now if I want to see a preview of this, I just enter to go back into the preview, and if I want to change the radius here, I can either pull these handles or I can use set all, and I can set the radius to, for example, 8 and change that radius. One of the headline features of Rhino 6 is that Grasshopper is now included. Many of you will already be using Grasshopper and will be familiar with what it is and what it can do. If you're new to Grasshopper, then in simple terms, Grasshopper is programming. In Grasshopper, you can create algorithms that perform actions inside Rhino. The good news is that you don't need to know anything about writing code or programming, as Grasshopper has an extremely intuitive graphical user interface. You do, however, need to have some knowledge about Rhino, since you are driving Rhino functionality and commands externally from Grasshopper. Let's have a look at a really simple example of why you might need Grasshopper. Here we have a simple stainless steel sports flask that has a textured rubber grip. In Rhino, we could array the grip texture in a number of ways quite easily, but performing iterations of size, length, and the array of this feature would be time-consuming and perhaps ultimately frustrating. So, rather than doing this internally in Rhino, we could create a definition in Grasshopper that would allow us to alter the variables with simple sliders. If we look at this definition, we can see the equivalent of the various steps we would need to perform manually in Rhino. So, first of all, this is the surface that we're referencing, the cylindrical surface of the flask. And the first task here is that we're dividing the surface and creating a number of points in the U and the V direction of the surface. Next, we're creating a line, and that line is created from each point and also in the normal direction of the surface. And that line has a length that we can control by this slider here. Then finally, we're creating a pipe around each one of those lines, and we can control the radius of the pipe with this slider and the cap style of the pipe with this slider. If I just go into the pipe component here and turn off the preview, it will be a little easier to just show you that by moving these sliders here, we can control the number of points in U and V, and we can control the length of the line here. And so if I turn the preview for the pipe back on now, you'll see we have a rather ridiculously exaggerated grip. I've now reset the slider values to something a little more sensible. At this stage, the geometry exists as a definition inside of Grasshopper and a preview inside of Rhino. If I actually want to create the geometry in Rhino so that I can save it within Rhino, then I select the geometry in question. So in this case, what I'm most interested in is this pipe component here. And then in Rhino for Mac, I hold down Option and Spacebar to bring up the wheel menu, and I can bake the geometry into Rhino. This now takes the geometry that was live in Grasshopper and creates physical geometry in Rhino. If I just turn off the preview now in Grasshopper, you'll see that we have now all of these poly surfaces created in Rhino. And so if I want to produce further variations, I can just keep on producing iterations inside of Grasshopper and baking off that geometry into Rhino. The Rhino and Grasshopper files are separate, and just like the Rhino file, the Grasshopper definition can be saved and reused. If you're interested in exploring the possibilities of Grasshopper, then at Simply Rhino we run regular Grasshopper workshops and training sessions, so please contact us for details. Rhino 6 introduces a number of enhancements in terms of display performance, display features and presentation. Firstly, and in very simple terms, all the display modes in Rhino 6 look much better, all objects are drawn much more smoothly, points and control points are properly anti-aliased, and overall the new display is much easier on the eye. There's a new display mode called Arctic, and this is great when you want to present an idea to show the form and shape without involving finishes, materials and textures. Arctic uses ambient occlusion and a discrete ground plane that by default snaps to the base of the object or objects being displayed. The pen display in Rhino 6 is much improved and now works correctly with block instances. The rendered display has undergone significant improvements in Rhino 6, and the default setting is now that of a typical product design setup. A 360-degree HDR image controls the global environment by default, meaning that at startup you have a predefined lighting and reflective environment solution. Once again, a discrete ground plane is automatically set to snap to the base of the model, although of course this can be changed. Materials have been significantly improved and simplified in Rhino 6, and the whole interface and methodology of applying materials is now broadly in line with that of Rhino for Windows. Here we have a model shown in rendered mode with no materials applied. So let's first of all have a look at a couple of ways that we can apply materials. So one way is that we can pick the objects in question. So I'm going to pick the bezel and the case of the watch here, and I'll also pick the case back. And then I'm going to go to Object Properties and Material and choose the plus symbol here, which allows me to either add a new material or to import a material from the library. Now Rhino 6 ships with a good selection of materials, and here I've got a folder with metal materials. I'll choose burnished and I'll choose burnished steel. And you'll see that material is now applied to the selected objects, and here in Object Properties I'll have the controls to the material. Let's now look at another way of creating materials. So I'm going to this time create a material for the strap. So I'm going to click on the little plus symbol again, but rather than importing a material from the library, I'm going to create a new material. And Rhino 6 makes this easy because there are a number of pre-built material types, so plastic, plaster, picture, paint, metal, glass, gem, for example. All of these are cut down versions of materials with limited controls, so it's very easy to make materials. If you're looking to make a more complex material, then the custom material here gives you all the possible controls for the materials. So here I'm going to choose a plastic material, and I'm going to give this a dark grey colour, and I'm just going to switch views here to my strap view, and I'm going to reduce the reflectivity of the material here by moving this slider to the left, and I'm going to add a bump texture, and I'm going to add a leather texture. Okay, now the leather texture has a scale applied to it here, and I can set that to the smallest value here, and you'll start to see the texture now looking a little bit more like leather. So I'm just going to increase the size of that. Okay, and then I just need to reduce the reflectivity of this. Actually, let's use the clarity instead. Let's pull down this here, because the reflectivity will help with the bump mapping on here. Okay, so now that looks fairly convincing. Okay, so that's our leather material. Next, if we zoom into the hands, I'll just want to show another feature of Rhino 6. So I'll just create a marquee around here. So I'm going to pick the minute hand, the hour hand, and the second hand, and I'm going to apply a material to those. So just for now I'll use the burnished steel material, and this applies the material to the whole of the object. If I just want to select individual faces of these hands, I can hold down Shift and Command and left click and sub-object select, and then I can apply a different material to these faces. So here I have my Lumibright material, and you'll see that although these objects are solid, I can pick individual faces to apply material to them. With the rendered display in version 6, we can create visuals quickly and easily. However, the rendered display lacks physically correct features such as real reflections, transparency, translucency, and refractions. In some scenes, for example such as those with glass and liquids, there is a need for a proper ray-traced rendering. Here you can see that the rendered viewport mode struggles with these types of materials. However, switching to the new ray-traced viewport yields much better results. The ray-traced viewport mode uses the Cycles render engine. This is a progressive path ray tracer and creates a number of render passes before completing the image. Ray tracing is computationally intensive, and so it may take some time to complete the passes. You can either let the render run to the set number of passes, or the rendering can be paused at any stage by pressing the pause button in the bottom left hand corner of the render window. Now you can see that the scene is now physically correct. The refractions can be seen affecting the path of the straw through the glass and the water. The water sits realistically in the glass, and there's subtle features such as the color bleed in the shadows. The default lighting and environment setup for ray traced mode is the same as with the rendered mode. The number of passes and other settings are accessed via Rhino's preferences. Here we can go to cycles and we can set the number of passes that the render is going to create. The default is 1000. I've set mine to 500, but you can very often get away with less than this. You can also choose whether your Mac is going to use its processor or the graphics card to compute the rendering. Rhino 6 introduces some new render time features, including curve piping, edge softening, shut lining, thickening, and displacement. These are changes that can only be seen in, for example, shaded and rendered mode, as the changes are made to the render mesh only and not to the geometry. So if we look at the wireframe for this geometry here, we'll just see a vertical helix curve here, two boxes here and a circle above it, and a single surface here. But when we move to rendered mode, you'll see that our curve is piped. This box has displacement applied to it. This box has edge softening and curve piping applied, and this surface here is thickened. All of these tools are available in Render Tools. They're all here, and each of them will have their own panel. So for example, here's the curve piping properties panel, and here, for example, we can change the radius of the pipe, and we can also change the cap type. One final feature that is extremely useful is that the materials in the Rhino material library that have textures mostly use WCS mapping. So let's pick an object and apply a material to this. I'll import a material from the library and I'll dig down into the architectural library. I'll go to wall, brick, English bond, and brick wall 3D mortar. Because this is WCS mapped, if I then take the same material and apply it to a number of differently sized objects, then the texture will always appear to be the correct size. So for example, with this brick texture, the bricks are the correct physical size, and I can apply the same texture to a number of differently sized objects without having to be concerned about using the mapping widget. Finally, for this video, I'd just like to look at another new version 6 feature, and this is called Snapshots. Snapshots combines saved variables such as layer states, visible and hidden objects, named views, named positions, materials, and rendering setups, so that, for example, you can quickly save variations on product colors, features, views, etc. These can be presented inside of Rhino, as is seen here, or these can be saved out to a full screen presentation. So that's about all I wanted to cover in this video. Please feel free to leave any comments below, and if you found this video useful, please hit the like button. To keep up with all the latest news on Rhino and Rhino related topics, please subscribe to this channel. Thanks very much for watching, and I hope to catch up with you in the next video.